Okay, Assalamualaikum warahmatullahi wabarakatuh. On this video, I will explain still under chapter 8, acid and base. Okay, this is about the dissociation of water. Okay, so water undergoes very slight self-ionization, or we call it auto-ionization. So this is the properties of water. It can undergo ionize, okay, by itself and produce hydrogen ions or hydronium ion and hydroxide ion. Okay, so let's be focus on the chemical equation. Alright, so we know that water is based on the Bronsted-Lowry theory. Water is amphiphotic. What is meant by amphiphotic? Amphiphotic, it can act as acid. It also can act as base. If for the H2O that act as acid, it promote or donate proton, okay, to the another molecule of water. Okay, and what happen is this molecule of water become hydroxide ion. Okay, so I will highlight the partner. Okay, acid have partner which is conjugate base. Okay, and then another molecule of water, okay, H2O is base. Okay, when it gain one proton, now it will form hydronium ion. Okay, or we can ignore the water molecule. Okay, this is another chemical formula. H2O will ionize by itself or auto-ionization to produce hydrogen ion and hydroxide ion. Okay, this is different compared to salt or acid, because acid ionized in water, salt also ionized in water, but water is already act as a solvent. So this molecule will act with another water molecule. Okay, so one molecule will become Bronsted-Lowry acid and one molecule will become Bronsted-Lowry base. Okay, this is how the water ionize. Okay, so the degree of dissociation is very small. Okay, please take note that, okay, degree of dissociation of water is very small. Okay, water can dissociate but the dissociation process is very small. Okay, and at the 25 degrees Celsius or 298 Kelvin in pure water. When I said pure water, this is mean neutral. Okay, so the concentration of hydrogen ion and hydroxide ion are equal at 1.0 times 10 negative 7. Okay, why negative 7? Okay, we recall back. Okay, pH equal to concentration of hydrogen ion equal to 1 times 10 power of negative pH. So this negative 7 refer to the 7 pH. Okay, this is neutral pure water, so that's why concentration of hydrogen ion and hydroxide ion is 1.0 times 10 negative 7, because we use this formula. Okay, so at equilibrium constant, Kw can be written for this reaction. Okay, what is Kw? Kw is called ionic product constant, okay, for water, and Kw has a value 1.0 times 10 negative 14 at 298 Kelvin. Okay, so to explain this, okay, I have to explain basically about the equilibrium. Okay, you have to know what is equilibrium. Okay, so what is equilibrium? Okay, equilibrium. Let's say reactant A react with B and produce produce C plus D. Okay, this symbol meaning reversible reaction. This is reversible reaction, or this is symbolic of the equilibrium. Okay, equilibrium. So there are two ways of reaction. Return from product, and product can can react to each other to form the return again. Okay, so what is meant by equilibrium? Okay, equilibrium meaning that the rate rate forward reaction equal to rate of reverse reaction. Okay. For the initial reaction, yes, of course, the rate is higher at return. But when the reaction when it undergoes the chemical reaction, the rate of return becomes slow. Okay, becomes slow because its amounts become less. Then what happens to the return? Okay, when the amount of product increase, it will react to each other and will proceed the reverse reaction to produce return again. Okay, until the rate forward reaction and the rate of reverse reaction equal, we call it, this situation is called at equilibrium. Okay, at equilibrium. Okay, so we can see that K is constant, concentration of A, coefficient will become power. Okay, concentration B equal to rate. Okay, concentration of C and concentration of D. Okay, this is formula that we can come out based on equilibrium. And K1 over K2 equal to equal to C times D and A times B. Okay, K1 over K2 is called Kc. Okay, alright. Okay, what is Kc? Kc is equilibrium constant. Okay, equilibrium constant. Okay, so this is how the equilibrium constant formula are derived from the equilibrium condition. Okay, so before that, I want to explain a little about what is equilibrium. Equilibrium must at closed system. Closed system. What is meant by closed system? Closed system meaning that reactant and product cannot expose to the surrounding, and surrounding also cannot enter into the system. Okay. This is second. Okay, concentration. Concentration of reactant and product is constant. Okay, constant. Third, rate. Yes, rate forward reaction equal to rate reverse reaction. Okay. Last but not least, equilibrium position is equal. Equilibrium position is equal for return end product. So the equilibrium position, I will explain it later on strength of acid and base. Okay, so this is the equilibrium constant. Okay, but when the reaction involve water, okay, let's see, reaction of water, H2O liquid, okay, produce hydrogen ion plus produce hydroxide ion. Okay, there is no power here because the coefficient is 1. Okay, so based on equilibrium constant, we can come out the formula. Okay, H2O. Okay, for water, this is specialized for water. Concentration of water is very small. Okay, very small, meaning that we can ignore this concentration. So when we ignore the concentration of water, it will become Kw. We not call it equilibrium constant anymore, but we call it ionic product constant. Okay, this is ionic product constant. So actually this is derived from the equilibrium constant, right? So here, okay, and the Kw or ionic product constant have a value 1.0 times 10 power of negative 14. Okay, where we can find this value. Okay, we know that concentration of hydrogen at pure water is 1.0 times 10 negative 7 times 1.0 times 10 negative 7 from hydroxide ion. By using the law of index, negative 7 plus negative 7, plus negative 7, equal to 1.0 times 10 negative 40. So this is the value of ionic product constant, or Kw. So from this formula, this is constant. This is constant, but make sure at 25 degrees Celsius. When the temperature is higher than 25 degrees Celsius or lower than 25 degrees Celsius, the value of Kw is changed. This is specialized for 25 degrees Celsius or 278 Kelvin. So from this equation, from this formula, we also can calculate the concentration of hydrogen ion or concentration of hydroxide ion. Alright. So Kw refer to the water produce hydrogen ion and hydroxide ion. This is at equilibrium. Remember that this situation is at equilibrium and at 298 Kelvin, and the value is 1.0 times 10 negative 14. Alright. So for the number 5, I already explained before, so I won't go through about the number 5. I already explained it. Alright, so proceed number 6. We can understand whether solution are acidic, alkaline, or neutral in terms of the relative concentration of hydrogen ion and hydroxide ion. A solution is neutral. Yes, neutral if concentration hydrogen ion equal to hydroxide ion. Acidic if concentration of hydrogen ion greater than hydroxide ion. Alkaline if concentration of hydroxide ion greater than concentration of hydrogen ion. Right? Whatever the value of hydrogen ion and hydroxide ion, it will produce the same value of Kw, which is it will produce 1.0 times 10 negative 14. Meaning that if the concentration of hydrogen ion increase, concentration of hydroxide ion must decrease, and vice versa. Okay. Alright. So this is exercise. Okay, exercise. Okay, so for the exercise, I will proceed on the next video. Okay, so that's all for introduction of ionic product constant from me. Thank you.